All right, this is topic 2.4. I've divided, we kind of have four different examples. We have solving the quadratics using imaginary numbers. We have the operations then, adding, subtracting, multiplying. The third part is the division, dividing complex numbers. And then the fourth part is factoring, using complex numbers as factors. Okay, so the first part here, we have x squared minus 4. And the big problem is, right, if you were to solve this normally and you take the square root of both sides, right, the inverse of a square is a square root, we can't take the square root of -4 and find an answer on our number line, right? The square root of -4 does not exist on a number line. So we have to use imaginary numbers, which aren't really necessarily imaginary. They're just a different type of number than you would find on a number line. We need to use those, what we call imaginary numbers, to solve this quadratic. So let's do so. So we're going to have x squared equals -4. Okay, we take the square root of both sides. So we're going to get x equals plus or minus, right? Because you could have a positive version or a negative version. And what we're going to do is we're going to split up the -4 into the square root of -1 times the square root of +4, right? -1 times 4 is -4, so this is all good. And then we're going to use that imaginary number I, which equals the square root of -1, okay, to answer this question. So now we have x equals plus or minus. Square root of -1 is going to become I. Square root of 4 is going to become 2. So we're going to have x equals plus or minus 2i. Right, we're just going to write the 2 in front of the I. That's just good formatting. And then my two answers then are going to be positive 2i and x equals -2i. Right, and then that's what we're going to write in as our solution set. 2i, comma, -2i. And there we go. Perfect. Okay. All right, let's look at a couple more examples. So let's see here. Okay, let's look at this one. Okay, so I have x squared equals -100. All right, so if I take the square root of both sides, I'm going to get x equals plus or minus. And I'm going to split square root of 100 up into square root of -1 times square root of 100. So I'm going to get x equals plus or minus I, right? The square root of -1 is I. And then the square root of 100 is 10. So then x is going to equal plus or minus 10i. Right? So x equals 10i. And x equals -10i. All right, let's look at a different one. Okay, let's look at one like this. X plus 27 equals 0. X squared plus 27 equals 0. So the way I'm going to solve this is I'm going to subtract 27 from both sides to move that 27 to the other side. So I get x squared equals -27. And then when I take the square root of both sides, right, what I'm going to end up with is x equals plus or minus. I can split this up into square root of -1 times square root of 27. Right? However, square root of 27 is not a perfect square, so I need to find two perfect squares that go into 27. Right? So again, our perfect squares are 1, 4, 9, 16, 25, 36, 49. Those are my perfect squares. The biggest perfect square that goes into 27, though, is going to be 9. So I'm going to split this up into square root of 3. Oops. Let's do square root of 9 first. Square root of 9 times square root of 3, right? Square root of 1 times square root of 9 times square root of 3 is going to be square root of -27, so we're good. Okay, so let's take those square roots. Square root of -1 is I. Square root of 9 is 3. And then I can't take the square root of 3, so I'm going to leave it as radical 3, square root of 3. That's going to give me x equals plus or minus 3i times the square root of 3. So x equals 3i square root of 3, right? And then x equals negative 3i square root of 3. All right. Let's do one more where we have to factor out something else first. Let's see. Yep, this is a good one. Okay. So I have 4x squared plus 36 equals 0. On this one, right, we have 4x squared and 36. They have a common factor of 4. So I can divide everything by 4, every term by 4, right? That's going to give me x squared plus 9 equals 0. Then I can move the 9 to the other side. Okay, and then now we can do what we did on all the other ones, right? We can take the square root of both sides, right? So you get plus or minus square root of negative 1 times square root of 9, right? And we get x is plus or minus 3i. Okay. But that's how you solve using imaginary numbers when you can't otherwise do it with real numbers.